So I'm just going to run through in writing before I show you a SOLIDWORKS model of what happens in question A4. And before I draw it, the drawing on the right shows the incomplete projections of a similar inclined cube of the atomium structure in Brussels, which is based on an inclined cube. Complete the elevation of the cube. So I just want to show you what or talk through what this is here. So this is an auxiliary elevation here, and it's projected from plan. So the plan being here. And then we have to complete the elevation of the cube. So the heights between an auxiliary elevation and an elevation are the same. So we're going to take our heights from the auxiliary elevation to our elevation, and then we have to draw the plan and elevation of the smallest possible sphere that will contain the cube. So that will be the last part that I will do on the drawing, and I will show a SOLIDWORKS model how to explain that, but it will involve me drawing the sphere here in my auxiliary elevation, find the long diagonal, find the center point of the long diagonal. Okay, the long diagonal is what joins two opposite corners together, and drawing the sphere in all views. The sphere projects as a circle in every view, and parallel lines are parallel in every orthographic view. So that's what the cube looks like in 3D. Here's the auxiliary elevation coming up, there's the auxiliary vertical plane. The plan is being shown there, so we're given the plan first. There's the auxiliary elevation. Here's the plan. Obviously I know the auxiliary elevation is on the other side of the sheet. Okay, now I've turned it around to show you the elevation and the auxiliary elevation share the same heights. And there's the elevation turned on there. So the auxiliary elevation and the normal elevation share the same heights. And this is part B about the sphere. So there's the sphere in 3D. It's going to be shown to you now in your auxiliary elevation. So the sphere there. There it is in elevation. There it is in plan. And it contains the cube. The sphere contains the cube. So that's how you know it contains the cube. And the center point is found by getting the long diagonal, the dashed lines there. And the radius remains the same in every view for the sphere. And then I will go on to drawing it. So to start there, I'm going to label the points, okay, that I have in both the views. I'm going to continue essentially my projection lines. Join the points up to the auxiliary elevation means they're the same angle as the existing ones, and I'll label the numbers. And then if you have a point in plan, its position elevation is directly above, so I just bring it straight up. And now I'm going to mark in what points I already have in elevation. So I have 2, 4 and 3. And then I'm going to take my heights from my auxiliary elevation. So I take the height 5, find 5 in plan and mark it directly above an elevation. Take the height of 8 and 6 there and mark them there. And I'll label them in as I go along. And that's 0.7. And then I have 0.1 left to do. So that's 0.1 done. Then I'm going to join these together. If point joins together in two views, it joins together in every view. So 1 joins to 2, 2 joins to 6 in plan, 1 joins to 5 in plan and the auxiliary elevation, 5 to 8, 8 to 3, 8 to 7. So 8 to 7 joins together, 7 to 4 joins together. 3 joins to number 1, and then 6 joins to number 5, and I think that's number 7 joins to 6 there. So parallel lines are parallel in every orthographic view. 7 to 5 and 3 to 8 are parallel in all the views. Now where I'm pointing my pencil there, I can see that face 1, 3, 2, 4, so I can mark that in as heavy. I can see line 1 to 5 as I look in from the auxiliary elevation, so I can heavy 1 to 5. Then I can see 5 to 8 and 8 to 3 as heavy. I'll be able to see 3 and 4 as heavy, 8 and 7 as heavy, and then you can see the hidden detail yourself there. And then we'll do the sphere. Okay, so in order to see the sphere that contains the cube, I need to see the long diagonal. Now that is a line that joins two opposite vertices. So you need to see the long diagonal as a true length, and it is a true length in the auxiliary elevation because it appears as a point in plan. So I can bisect the line to find the centre. Now there is easier ways. You could join the other line 1 to 7 to get the centre point, but I think it's a good way to do that. And then the centre of the sphere is there in the centre of the long diagonal, and it's contains the sphere, so I can bring it out to 0.5. And then the height of the center point of the sphere is found by transferring it from the auxiliary elevation to elevation, and then it's on line 5 to 4 in plan. Okay, and the radius remains the same. Okay, and that's it then.